Let's take a look at this problem where we want to find the x values that satisfy the sum of 5 times y1 and 4 times y2 is the product of 6 and y3. And we want to replace y1 with 1 over x. We want to replace y2 with 1 over 7x. And we want to replace y3 with 1 over x minus 7. Now, we can think of 5 as being 5 over 1, 4 as being 4 over 1, 6 as being 6 over 1. We have to think of it that way, but we don't have to necessarily write it. But if you feel more comfortable writing these integers in this fractional form, then of course do so. When I multiply fractions, I multiply numerator times numerator and put that over the product of the denominator times the denominator. So this gives me 5 over x plus 4 over 7x equals 6 over x minus 7. And one of the things in a rational equation I have to think about is restrictions. And those are the values of x that can't be accepted as solutions because they make at least one denominator in the original equation 0. So if x is 0, both first and second denominators are 0. So if it should come up as a possible solution, I'd have to reject x equals 0. So x cannot equal to 0, or else the original equation won't make any sense. It'll be undefined. Also, x can't be 7. If x is 7, that would make this denominator 0. So those are my two restrictions. So as long as my solution isn't one of these numbers, then I have a value that I can accept. If one of these numbers shows up as a solution, then I have to reject that solution. Now my LCD has to have every factor in it that's in any of the denominators. So the first denominator has simply an x in it. That has to be in the LCD. The second denominator has 7x. Well, x is already recorded in the LCD, but now I have to make sure the 7 is a factor of the LCD, since that's a factor of the second denominator. X minus 7 has not been recorded yet as a factor in the LCD, so now I place that as one of the factors in the LCD. So every term gets multiplied by this LCD. And because the LCD contains every factor that's in any of the denominators, each denominator is going to divide evenly into the LCD. And that's the whole point. So this is the smallest expression that each denominator divides into evenly. Alright, so I've written that each term is going to get multiplied by the LCD. And remember, each denominator is going to divide evenly into the LCD, so all denominators will be eliminated. So this x in the denominator divides and gives 1 with this x in the numerator of the LCD. So remember, anytime there's not a fraction bar, what I have is in the numerator. You can write that over 1 if you would like, but it's not necessary to write it. This 7x in the second denominator divides evenly into this 7x in the numerator, leaving a 1, and 1 times these other factors in the numerator will give me these other factors in the numerator. So I can just leave that 1 unwritten. Only time I have to write the 1 if it's the only remaining factor. So x minus 7 in this third denominator divides with the x minus 7 in the LCD. So I'm left with 7 times x minus 7 times 5 plus x minus 7 times 4, which equals, oops, this is just a 6 here, not a 6x, which equals 7x times 6. So I can multiply in any order. So 7 times 5 is 35. Multiplication is commutative, so it doesn't matter what comes first in the product. So I'm going to move this 4 and make it first in the second product. And then 7x times 6 is 42x. So I'm going to use the distributive property. 35 times x is 35x. 35 times negative 7 is negative 245. 4 plus 4 times x is 4x. Plus 4 times minus 7 is minus 28. On the left side, I'm going to combine like terms. 35x plus 4x is 39x. Minus 245 minus 28 is minus 273. And that equals to 42x. Let's subtract 39x from both sides. So we have just a number on the left, or one side of the equals, and a single x term on the other side of the equals. So negative 273 equals 3x. And if I divide both sides of the equation by 3, I obtain negative 91 is equal to x. So my solution set is the set that has negative 91 in it. And that's how you would work that problem.